Welcome back, Mustangs, to another edition of No Hair, No Problem. Today we're going to be starting with Chapter 9, which is there's just going to be three sections of this chapter. It's pretty quick. When we're dealing with conic sections in this section, I'm sorry, conic sections in this section. Get it? I didn't think about that. Anyways, in this section, we're going to be talking about circles and parabolas. The next section, we're going to talk about ellipses, and then in the last section, we're going to talk about hyperbolas. So real short, just a review of conic sections. The hardest part of this entire unit, I firmly believe, is parabolas. There's a lot to know on there. I'll give some general notes, and then we'll try to go over some more problems in class together, okay? But let's get started, all right? Oh, by the way, my hat, I'm not wearing a hat today. I chose to wear my hood instead. I'm wearing a Snuggie with my hood on, block out all the possible lighting that could possibly take in place here, all right? I look like I was almost like a wizard, like a farm wizard. Anyways, all right, let's dive in. So circles and parabolas. So when we're talking about conics, the idea of conic comes from where we talk about cones and the shapes of the cones, and then if we took slicings of cones. So, for example, if I was to make a cone that looked like this and another cone that looks like this, and I went ahead and made like a slice through it, if you could imagine it, it would be like a curve like this and a curve like this. That's a hyperbola. If we made a slice straight through, that would make a circle in here, that circle. If I made like a diagonal slice through one of them, it's going to be an oblong circle. We call that an ellipse. And then a parabola is if I just go ahead and make a slice diagonally through a portion of this and it makes like a little curve, that's just a parabola. So we're going to kind of just dive into each of the conic sections and the rules regarding them. But here's the deal. Anytime we're talking about conics in general, there's a general formula we look at, which in this case is ax squared plus bxy plus cy squared, blah, 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 blah. What you have to realize is that there's certain things that we have to recognize within these. So when we have two squared terms, that means that it's either going to be a circle, an ellipse, or a hyperbola. If we have no coefficients in the front of these, so the a and the c here are coefficients of the squared terms. If there's no coefficients, then we have a circle. And well, not necessarily, but we'll go into examples there where you can tell the difference. And if we have a minus in there, we have a hyperbola. And if we have values that are attached to them that are different, I should have said if a and c were the same, it would be a circle. But if a and c are different, it's going to end up being an ellipse. If there's only one squared term in there, we're going to end up with a parabola. Okay, so a locus in these cases is the collection of all the points that actually satisfy and make up this shape. So for example, the definition of a circle is the collection of all the points that are the same distance from the point in the middle. And so what we talk about are the names of each of those parts. In this case, the first thing we're talking about is in the circle, this is the equation of a circle, is the h and the k are the center, and the r right here is the radius of the circle. Okay, now we should know the names of each of the parts of a circle, right? Like when we look at a circle here, we know that this distance from the center to the outside is known as the radius. We know that the distance all the way across is called the diameter, and the radius is always half of that. We have x and y, which are a coordinate on my circle, and every single one of these points on here is a series of all the x's and y's that are all exactly the same distance from the center. Now, you'll notice we kept using the word distance, 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 distance. Well, the distance formula is actually used throughout this to actually get us the formula of a circle. So how do we use it? Well, think about your distance formula. You have the square root of x, and normally what happens is we have a point in here, which is called x1 and x2, and then we have y1 and y2. Well, one of my points in this case is technically called h and k, or the center of my circle. So if I'm trying to find the distance between a point on the outside of the circle and a point in the middle of the circle, instead of me using an x1, x2, and a y1, y2, I use an x1 and an h, and then a y and a k. H and k are the point in the center. And that's going to be the radius of my circle. So if I want to get the actual formula for the circle, get it out of that distance formula, we link it back to the fact that we have an r here, and if I square both sides, we end up with this formula, which is x minus h squared plus y minus k squared equals r squared. That's the formula of our circle. If my center happens to be at 0, 0, that means that this right here, oops, that's not the bad. If this will be a 0 and then this would be a 0, well, if we just clean that up, this will go away and this will go away, and we're left with a formula that says x squared plus y squared is equal to r squared. Now, finding the standard formulas, this is the hardest part about circles, is taking the information and just putting it directly into a formula. What we know when we look at this first example is that the 0.14 is on the circle, and the center is at -2, -3. It helps you if you actually write in what each of these parts are when we're doing these. So when we say the center, we're talking about h and k. All right, and when we're talking about point, we're talking x and y. So think about how this translates into our formula. You have 1 and 4, -2 and -3. They're going to go into this formula that we have up above. Now, just be careful of your signs when you're doing these. So the radius of the circle is the distance between these 2 points. So we go ahead and use our distance formula, and we put in our values. Okay, remember we've got, so we got 1 minus -2. So that's 1 minus the -2 is going to go in here. And then we've got the 4 minus the -3 is going to go right here. That's going to go ahead and get us our radius for this problem. Okay. And so we go ahead and simplify. We end up with 3 squared plus 7 squared. That's a 9 plus 49. So we end up with the square root of 58 is going to be our radius. Now let's go back and put these into the actual formula. If the h and the k are in the -2/3, let's start with the equation first, which is x minus h squared plus y minus k squared equals r squared. If we take our h and put it in for h, and we take our k and we put it in for k, and then we're going to take our r and put it in for r, what's going to happen is our formula is going to look like this, putting in that -2, the -3, and the root 58. Now we can clean all this up. Let's try to get away from any double signs, okay? So like this double sign that we see right here will just turn into a plus. The net double negative that we see right there will turn into a plus. And then this root 58 squared, well, if you square a square root, they just cancel out. So the cleanup formula is going to be this. We have a radius of square root of 58. We have a center at -2 and -3. Okay. Now, what if I'm given this wonky thing, and I'm asking you to find the center and the radius? Well, this is where we have to be systematic and organized. And in order to do this, this is going to be one of those things that we all have struggled with throughout the semester. And I said, you better get used to it because you're going to see it. That's completing the square. Okay. Now, how do we actually go about doing this? When you're taking these, and you're going to see this with hyperbolas and ellipses, when you've got a hot mess going on, put stuff together that belongs together. What I mean is, like, take your x's and make sure that they're together. Okay. Take your y's and make sure that they're together. And this little constant that's right here, don't let it be there by it. Move it away from everything over to the other side. So if we do that, here's what that's going to look like. The x squared minus 6x is going to look like this. And that 6 is going to move over and be a -6. Okay? And then the y squared minus the 2y is going to be like this. Now, you should recognize this blue box. This is when we do the whole completing the square concept. That if you recall, to complete the square, we take half of the value that's here. So half of -6 is going to equal -3. And then we're going to take that -3 and square it. And what we're going to do is we're going to add in a 9 right here. Okay, half of the value and then squared. So half of -2 is -1. Square that, we're going to add in a 1. Okay. Now on the right side, remember that when we are completing a square, if I add 10, because I've added a 9 and a 1 to that left side there, if I added 10 to the left side, I could do the same thing on the right side of my equation so that these are balanced, right? If I add 10 to one side and not the other, it's going to be an offset scale, so we have to balance them by doing the same thing to both sides. So I'm going to add that 9 and 1 to the right side as well. Why did we do this? Well, we're completing the square. We now made this x squared minus 6x plus 9 a perfect square trinomial. And we made that y squared minus 2y plus 1 a perfect square trinomial. And so in order for us to continue on with this, to write this in our perfect standard form, we go ahead and take and do the conversion of this trinomial into this binomial. That this b value, that's right here, that -6, if I take half of it, I get this -3. And if I take this right here and I cut this b value in half, I end up with a -1. So now when we look at this, we can tell all the information that we need to know. My center is going to be at positive 3, positive 1. And my radius is going to be the square root of this, which is just 2. Okay? That's it. Circles are the easy part here, you guys. Now let's talk about how we graph it. Okay, if I wanted to graph this, we know that the center, again, is at 3, 1. We know the radius is equal to 2. So think about what this looks like. If I go on my picture and I go to 3, 2, and I say, let's go ahead and draw a picture for this. Well, we're going to need some points to make a good graph. If the radius is 2, I said 2, I'm sorry, it's 3, 1. If we're going to make a graph for this, and we know the radius is 2, we should go 2 in each direction. So 2 here, 2 here, 2 here, and 2 here. And this is going to give us our graph that we can kind of graph and make it look like a circle. The hardest part is like getting these curves to be nice and straight, but if you do it on Notability, it just snaps it into place. So I can do this, hold it down, snap it, and it makes that circle that I can resize to where I need it to be. Okay? And then this is what the graph would actually look like. So if I went 2 in each direction, these would be the points that we would use. 5, 1, 3, 3, 1, 1, and 3, negative 1. That's circles. Now, let's jump into parabolas and all the parts of the parabolas and how confusing it can be, but how absolutely amazing parabolas are. Parabolas are so important in our lives. Some of us couldn't see, such as myself, without parabolas. Our eyeball is shaped like a parabola. When you look at a parabola, if I looked at it like an eyeball, right? So this is a eyeball, you got eyelashes here, and then you got eyelashes here, and you got like the whatever the opening's called, I can't remember. We have light that goes into your eye in all these different directions. And then what happens is all of these come down to a point right here, which is called your focal point. This is the point that then gets reflected out into your brain. This is a brain. That's my terrible version of a brain, so that we can see things. And they tell you that you should never squint when you're outside, because what's happening is as you're squinting, you're taking this parabola and you're actually squeezing it down. And you notice that when you do that, things become a little bit blurry. It's not just your eyelashes. You're changing the shape of that, which means you're also changing the focal point that's in the back of your eye. When you're wearing a contact, the way it works is it squeezes your eyeball. It takes your eyeball and actually squeezes it, and it changes that focal point. And the thickness of it will help to either squeeze it or make it a thicker area in the front here, so that it changes the way that light goes in and hits a focal point in the back of your eye. Well, what does that focal point do for us? Let me show you a little quick video here before we jump in. If you look at this video here, all of these points are, just imagine, are light coming in. And then what's going to happen is as they reflect off of the parabola, they're going to bounce back and they're going to hit this one point back in the middle here. That again is called, I don't want to go back. I want to watch the video again. Let's do that one more time. All right. So all these points are coming in. They're all going to hit, and they're all going to hit this point, that black point right in the middle there. Boom. That point right there is called our focus. Okay. So imagine you had a flashlight. You want to focus it. You squeeze it in. You make it more condensed, and all the points will go into this. Okay. So they're really important in our lives. So let's talk about the parts of the parabola so we all understand these, okay? Let's dive into this. So when we look at a parabola, there's a couple of parts that are super important that you need to know, okay? The first is this point right here. This point at the bottom of my curve, or the top, or this side, this is called the vertex. This is where my graph changes direction. So as I move this way, it's going down, and then what happens is over here, it starts going up. If this had been a sideways parabola, the change of direction would be as it goes this way, it then switches gears and go back the other direction, okay? That point on my parabola is called a vertex. The point that's out here is called my focus, okay? Now, what is my focus? And what is this thing over here called the directrix? You should notice something, that these two values right here look like they're about the same. And the fact is, they actually are exactly the same. But what does that do in terms of the shape? Well, it creates this pattern that actually happens, which is pretty remarkable, that this distance right here is actually equal to this distance right here. This distance right here is equal to this distance right here. And so for every single spot that I go ahead and take and draw a line, if I drew this line right here and I connected that line over to my focus, guess what? this is going to be exactly the same as this. And it keeps generating these isosceles triangles within my picture. So if I looked right here, you can see that there's an isosceles triangle right here. If I looked right here, you can see that there's an isosceles triangle right here. And I can do this an infinite number of times. And every single one of these points, if it comes back in this direction, it's going to bounce back to here. If it comes in this direction, it's going to bounce into here. If it comes in this direction, it's going to bounce into here. Pretty remarkable stuff, okay? Now, there's a really cool other relationship that takes place in here. So this distance from here to here and here are the same. This distance we're going to call P. Now, the length that actually takes place across here, believe it or not, is related to this right here. This length across is exactly 2 times P. It's always the same. So this value right here is P. That distance across there is known as 2P. So then I take this right here and go across. This is also going to be 2P, which means if I put these two together, this is going to be 4P. There's a name for this. We call this the focal width. It's the distance that my parabola is from my focus. So it's half to one side, half on the other. So it's basically essentially saying how wide my parabola is at the focus. And that is going to always be parallel to my directrix. That 4P is very important. It tells us whether my parabola has been stretched out or shrunk, okay? So let's dive into some problems that actually talk about these parts, all right? So the formula is, first off, is x minus h squared equals 4P times y minus k. When we have x being squared, that means that the parabola is always going to be like this or like this. It's always going to open up and down, okay? When we have x squared in the problem. When we have y squared in the problem, this graph is always going to open side to side, okay? If my 4P is positive, it's going to open to the right, and if my 4P is negative, it's going to open to the left. You know, the reflection piece that we talk about. In this one, if the 4P is positive, it's going to open up, and if the 4P is negative, it's going to open down, okay? I gotta tell you, like when it comes down to doing this problem, sometimes the best thing you can do is draw a quick little doodle, and all the information just kind of jumps off the page of you and tells you exactly what the function is. You know, are we dealing with the y equals? Are we dealing with an x equals? Is it opening up, down, left, or right? Like all that information jumps out if you do a quick doodle. So let's go ahead and take a look. This is some more of what I talked about. That you can see how it opens in the upwards direction, downwards direction, right direction, and left, okay? And you can reference these again. So it says, find the standard form of the equation of the parabola with a vertex at the origin and a focus at 0, 4. So before I even do anything equation-wise, let's draw what this kind of looks like, okay? So we can get an idea. My vertex is at the origin. My focus is at 0, 4. That tells me that without even doing anything, that this distance right here is equal to 4. And that tells me right here that this distance is equal to 4 as well, because remember, those distances are the same in each direction. My focus has to be in the middle of my parabola. So that tells us that my parabola has to open like this. So it opens in the up and down direction. And that this right here is going to be my directrix because they're going to be equidistant from each other. I should have done it in a different color. Give me one sec. That this right here is my directrix, and that's a horizontal line. So my directrix for this is at y is equal to negative 4. My focus for this is at 0, 4, as we just said, okay? The width for this, now think about this. I told you that this distance right here is twice that value that's going from here to here. So that means that this is 8. And that means that this entire distance right here is also 8, which means the entire distance across is equal to 16. That tells you that 4P is equal to 16, and that my P value is equal to 4. Okay? So now let's see this all in action. Let's start with first the fact that we know that 0, 0, and 4, 0, 4 are on my graph. Okay? We know that the standard form, because it opens that up and down direction, is going to be that x squared equals 4p times y. And since my vertex is at 0, 0, which let's go back here, you can see that was the equation right here. This is when it's at 0, 0. If we take all of the information and plug it in, if x squared is equal to 4py, We know that the P is equal to 4 because it's from the origin, my vertex, to the focus is 4. Then this 4 times 4 is going to equal 16. And this is my equation. X squared is equal to 16y. That's it. So now if I want to try to graph this, if you have to put this into your graphing calculator, you have to solve for y, which means you would divide both sides by 16. And if you have Desmos, you could just throw this whole equation in. It will graph it automatically for you, and you should see that your graph actually looks just like this. Okay? All right, now, how do we convert these over to the standard form? Again, this is complete in the square. And again, anytime we have fractions, just get rid of the fractions. Fractions are terrible. So let's go ahead and get this in the standard form. Now you can see we have an x squared going on right here. That means that we're going to ultimately try to get it in this form. This x minus h squared equals 4p times y minus k. This is our goal, is to get this equation. Okay. So if we start with the original equation, what we're going to do is let's get rid of the fraction. If we multiply everything by 2 in this, we'll end up with a 2y, the 2's will cancel there, a 2x, and the 2's will cancel there. And we are now left with this equation. And I'm sorry, I multiply both sides by a -2 just to get rid of this negative that we have in the front right here, because it's always best to complete the square when we have a positive there. So I multiplied everything by actually a -2. Okay. All right, so let's continue on. In order to complete the square, if you remember, we always have to try to get this portion of the problem by itself. So that means we're going to take the 1 that's right there, and we're going to go ahead and move this over to the other side. So that means that now we're going to have a positive 1 minus a 2y, and it's going to equal x squared plus 2x. Let's continue on. Now we're ready to take and complete the square. We're going to take this side over here, and we're going to complete the square by taking half of the 2 that's there and adding, and then squaring it, and then adding that to both sides. So if we do that, that's going to give me a 1. Half of 2 is 1, squared is 1. I'm going to add a 1 to both sides. Go ahead and simplify from here, combining our like terms. We'll have a 2 minus 2y equals x squared plus 2x plus 1. So from here, we're ready now to take this trinomial and write it as a binomial squared. And this right here, that 2 that's in there, why don't we take that out? Not only that, let's go ahead and put this in a standard form of -2y and a positive 2. Put that y first. And you can see that we're supposed to factor out a -2 from here. So what does this look like? Well, I take the -2 out. We're left with a y minus 1, and that's going to equal x plus 1 squared. That's that form that we were looking for back at the top there. So now what does this tell us? Let's pull some information. My vertex for this, if I pull information, is going to be at -1, positive 1. Okay. Since this is squared, we know it's either opening in that up direction or down direction. But because this is negative, that tells us it's going to actually open in the down direction. So 1, -1, and it's going to open in this down direction. Okay. From here, let's compare to try to get where the vertex is and where the directrix is. Okay. The vertex for this, I'm sorry, I said vertex, I think. I meant focus and directrix. Sorry. Okay. When we look at the 4p that's going on right here, this 4p and -2 are supposed to be equal to each other. So if 4p is equal to -2, that tells me that p is equal to -1/2. Okay? So think about what this means. From my focus, from my vertex, we're going to go half in this direction, and then we're going to go half in this direction here. Half in each direction because that's what my p-value says. It's half in each direction. That tells us that my directrix is going to be over here and that my focus is going to have to be here because the focus has to be inside of my curve, okay? If I know that the coordinate that's right there for my vertex, we said is at -1, 1, and I have to go down a half of a point, p, so go half a point down, what I'm going to do is I'm going to actually go down another half. I'm going to go down, I totally just put that point in the wrong spot. You can tell it's late. I'm going to do the picture again. I have to go to -1, positive 1. I am so sorry. Let me regraph this, okay? This is why there's an edit button, but I don't believe in editing. I'd rather you guys see that I make mistakes just like you, and I'm sorry we have to erase just like everyone else does, okay? So if I'm going to go to -1, positive 1 for my vertex, okay? We know it's going to open in the down direction. Okay. The P is telling us it's going to go down 1/2 and up 1/2. So the directrix is going to be up here. Okay. My vertex is at -1, +1. Okay. This is my vertex. To get to my focus, we're going to go 1/2 a point in from there, which means we're going to take away 1/2 from my Y value. So it's going to be at -1, and then 1/2 is going to be at my focus. My directrix is going to be 1/2 up in the direction, which will put this as, if I added 1/2 to it, so that means that my Y is going to equal 1.5, which is just 3/2. Okay. And so all this together, we know that the H is -1, the K is equal to 1, the P is equal to -1/2. And we will go into exactly what I just said, that if I take my vertex and I move the P into it, we're going to have a -1 and 1/2. Okay. And then we can see the actual picture is going to look exactly like what we just went ahead and drew. Okay. That's it. So the only thing I would recommend is, as I said, when you're drawing each of these things, or when you're trying to work through it, this is just my recommendation from a history of doing these, draw a little doodle. Go and take your vertex and go P. If you know the 4P, then you can figure out what just one of the P's is. And if you know what one of the P's is, you can figure out what two of the P's are, then you can figure out what one of them is. Right? So again, if we looked at this, we know that this right here is equal to 4P. Whoops. This part right here is equal to 4P. We know that this portion right here is just equal to 1P. We know that the directrix would be over here, which is equal to just 1P. Okay? So there's all these connections from the picture. It just makes it a little easier to try to figure everything out, okay? That's it. I would recommend doing as many of the parabola problems first and then jump into the circles, because the parabolas are the ones that people notoriously have questions on, okay? You got this, though. I believe in you as always. You take care. Don't forget to like and subscribe to my channel, and you have a wonderful day.